Hi everyone, it's Sorkin. Today we are going to take a look at the recursion. So first let's start with the definition. So what is recursion? Recursion is an approach where a function calls itself to solve a problem. So for example, let's take this example where we need to write a recursive function that takes a string as an input and returns the string reversed. So for example, let's say we have input as hello and we are returning ole. So what we do is, so our function looks like following. So what we do is at each step we are taking the last character and we are recursively calling the reverse string. And if the size is equals to 1, then in that case we are started to return the value. So for example, our recursive stack in this case, right, it will look like for a world, it will look like following. So first we take the last character d and we are calling the reverse string function with the first 4 characters world. So the next one is that we are taking again the last character l and we are calling that for were. And the next one is that we are taking r, we are calling for wo, and the next one is that we are taking o and we are calling for w. At this step, so what we do is if the size is equals to 1, so we are started to return, right? So we are started to return from our last function. So what we do is, so we are returning from our last function, we are returning w, and in the next step what we do is, so we return w. So the next one is we started to return from the second function, from the second function from the last. So we are adding o to w. Now we have ow. Now we are adding r, right? So now we have row, and then we are taking we are returning from the second function, and from the second function, and we are adding l plus row. So and then now we are returning from our last function, and now we have reversed our word, which is world. So why stack is important? Why it's important to know that how exactly the stack is generated. So one of the reason is that, for example, in this case, if we calculate the time complexity is calculated based on the height of a recursive stack. So what is the height? Height is of the stack is the total number of the calls made. So for example, in this case, we are making 5 calls, right? Our number of the calls is equals to the height of our recursive stack, which is in our case is 5. So our time complexity in this case is of n, right? So number of the recursive calls that we are making. So how about the space complexity? Space complexity in this case, it will be calculated similar. The calculation of the space complexity is similar. So what we do is, so space complexity is calculated the depth of a stack, of the stack. So which is that how many functions, how many function calls are currently active in the stack, which is at the maximum size of a stack at any moment. So we may call the stack, so for example, at one moment our size of our stack is, let's say 5, and in the another one the maximum size of our stack is 9. So for the space complexity we are taking the depth of the stack, which is the maximum size of the stack at any moment. So let's say that in one case we are recursively calling this size of our stack is 5, in another is 9. So we are going to take 9 because that is the maximum size of the stack. So and the space complexity in this case is also of n. So another question is, why is recursion is important? Recursion is important because recursion is an essential component of important algorithms and widely used algorithms such as backtracking, dynamic programming, also DFS, depth first search algorithm, also for example for tree traversal and so on. So we are using recursion in all of these cases. So let's take another example. Let's say that we are given an array and we need to determine whether or not it has a subset with a sum equal to target. So for example, let's say we have an array 4, 8, 5, 6, 11, and the target is 15. So we need to find out whether or not we have a subset that is equals to our target. So what we do in this case, if we look at this problem, so our final subset either will include each of these elements or not, right? So for example, let's say that let's take the first element 4. So our final subset either will contain 4 or not. So we are making two calls. The first call is that the recursive call when we are including 4, and another one is empty, which means that so we are adding 4, right? So on the left and on the right, we are calling our function again with so we are calling our function again, but we are not including 4 to our subset. So again, the next element is 8, right? So we either include 8 to our final subset, or we are not or we are excluding. So if we are including 4 plus 8 gives us 12, and we are excluding, so which means that the 4 stay the same, right? So the next one is we are taking another element, which is 5. So again, we are recursively calling, right? For each case, we are recursively calling two cases. So either we are including that element or we are not including. So the next element is 5. So either we are including 5 to our subset, or we are not, or we are excluding that. So for example, in this case, 4 plus 5 gives us 9, and the next one is we are excluding for the right, so it's just 4, and the last one for 6, right? 9 plus 6 gives us 15. So 9 plus 6 gives us 15. So we are including that, and on the left we are not including that, so it's 9. The value of that is 9. So as we see that we found our target 15, and we are returning. So we are returning true because we found our target. In this case, for each case, right, we are generating two possible options. So either our final result. So basically what we do is we are generating 3 of all possible subset from an array, and we do that using a recursion, and we are either including the element so either we are including at each stage. So at each step we are either including our element or we are not including, as in this case. So the code for the above is that, so we are passing our nums, which is our array. We are passing our target sum, which is the target sum that we want to find out, and the temp sum is that the sum that the temporary sum that we have at the moment, and the index. So if our target sum is equals to our temp sum, we are returning true. If the temp sum is more than target sum, so which means that that subset cannot be our target sum, so we are returning false. Or if the index goes beyond so index is more than the length of our nums, then in that case we are also returning false. And for each case we are making two choices, right? So we are generating all possible subsets for in this case. So what we do is for include, we are calling again recursively calling our recursion, and we are passing num, we are passing target sum, and in this case we are including our current element. So to our temp sum we are adding our current element, and we are going to the next index. For the exclude, we are not adding that, so we are calling nums, again target sum, and just the temp sum, so we are not including our current element. If any of this is returned true, then in that case we are returning true, or otherwise we are returning false. So what's the time complexity in this case? The time complexity is if we have one element, if we have only one input, right, we are making two choices. If we have two, we are making 4 choices. If we have 3, we are making 8 choices. If we have 4, 16, and so on. If we have, let's say, 5 input, then it means that for each one we are going to generate 2 possible. So each case will each new element will generate twice more subsets. So our time complexity in this case is exponential, is to the power of n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.